Okay, let's just have a little look at straight lines then. Normally you've got your Cartesian coordinate and you've got your straight line. That should be a straight line there. There, say, suppose that's a straight line. So you can draw it on the axes, can't you? Your Cartesian coordinates and your xy axes, and you can draw a straight line. So here's one illustrated pictorially here, and we've chosen it to have a gradient theta. The slope of the line or the gradient is defined as, we usually label it m being the slope. It's actually the tan of theta, which is the amount that increases divided by the amount that increases. So it's the increase in y divided by the increase in x. When you draw any triangle underneath the line, it will be the same ratio. Okay, so find the gradient of the following lines. Well, this line here, if you're standing here and you're facing in the forwards positive direction, this line goes up, so got a positive gradient. It's the tan of that angle, isn't it? Tan 45. If you tap that in the calculator, you get 1. So the gradient is 1. Here, M2, if you're standing here facing in the forwards direction, again the definition is the tan of this angle. There you are, standing here on this slope, and it's tan 135 equals, and tan 135, let's just find out, tan 135 minus 1. So it's a negative slope, and that means the slope is going downhill. So you're facing forwards, it's going downhill, it's a negative slope. That's why that came out there. You could have actually got it from noticing that it's a negative slope and the angle's 45, and you just do a minus at tan 45. You could also do that if you wanted. Find the gradient of the line through this point here and the line through this point here. What angle does each line make with a positive axis? So that's the next question then. So let's scratch this stuff then, and we'll have some workroom up here. Okay, so I'm not going to scratch the formula, I'll try and scratch what's underneath. Okay, so we've got the gradient of the line through 1, 2. So here's a long one up 2, and there's a long 3 up 6, so it would be up here some, wouldn't it? So there's our line here. And this was 3 and 6, wasn't it? So the increase in y, how much do you go up vertically? We go from 2 height to a height of 6, so that's an increase of 4. And the amount you go along, the increase in x, is the difference between 3 and 1 is 2. So we'll call it m1 then. The gradient of this line, the first line, is going to be the increase in y divided by the increase in x, 4 over 2, which is 2. 2, 3 and 6, 1, so let's mark that. So along 2 and up 3 is there. Along 6 and up 1 would be up there, wouldn't it? That would be the line. Okay, so I'm going to draw a triangle underneath the line, because you always draw a triangle. Or you could draw the triangle above the line if you wanted, like so. Just so you draw a triangle. So the increase in x, we're going from 2, 3 to 6, 1. So the increase you go along in x direction is from 2 to 6, is an increase of 4. The increase in y, we go from 3 down to 1, so it's an increase in y of minus 2, because you're going down 2, aren't you? So m2 then is the increase in y, which is negative 2, divided by the increase in x, which is going along 4. So you get minus a half. That's the gradient. Negative slope, so it's going downhill. If you picture yourself on that slope here facing in the forwards direction, it's a downwards hill. This is a positive slope because you picture yourself here facing forwards in the positive x direction. You're going uphill, so it's a positive slope. What angle does each of these lines make with a positive axis? So we could find out the angle by doing shift tan 2. So shift tan of 2, 63.4 degrees, and theta 2, shift tan of minus a half. So let's see what that is. Shift tan of minus 0.5. Which, this is the problem, see. If you do shift tan of 0.5 then, 26 you see, so basically the angle that the line makes is it's going down by 26 degrees. So if you're measuring it from here, which is customary to measure it from, it's going to be 180 minus 26, which is 153 degrees. So theta 2 is 153 degrees. The calculator doesn't give you it because it's in the second quadrant. So if we could do shift tan, no we couldn't. We'll do tan of 153, let's just check it. Tan of 153, a rounding error should be in place, but you get minus 0.5 and a rounding error. So I hope you can see that that was 153 when it's a negative slope. It's in the second quadrant. Is the angle. Okay. So that's the angles in question, isn't it? Next problem. So let's have a look at this. So you picture yourself as positive x direction. That's how you always picture yourself, facing forwards in the positive direction. So if you have a line that goes upwards, you're walking up a slope, so it's a positive gradient. If you have a line that's going downwards, you can picture yourself here. You're actually walking downhill, aren't you? So you can reference that by saying it's a negative gradient. If the line's flat and there's no increase, then the tangent of the angle is 0 because it's flat. There's no y increases there. So it's 0 gradient. If the line in question, so you've got a flat line which is 0 gradient, but if it's a vertical gradient, the increase in x is 0, so you divide it by 0 and you get infinity. So that's an infinite slope. So as the slope gets steeper, the gradient gets steeper until it flattens out to 0. It goes up to infinity when it's vertical, and then it comes down to 0, and then when it starts going downhill, it goes negative more and more and more until it gets to minus infinity. So that's the array of possibilities you can have for the line in the context of you facing in the forwards direction that way. So that's parallel. Parallel lines have the same gradient. That's pretty clear, isn't it? Same slope. And perpendicular lines have the property that the products of the gradient is minus 1. So this question then, if m1 is 1 and m2 is minus half, are these lines perpendicular? Well, 1 times minus a half equals minus a half. And that doesn't equal minus 1. So no, they're not perpendicular. Find the gradient of the line perpendicular to a half. Well, a half, what do you need to times that to get minus 1? Well, times it by minus 2. So the answer would be minus 2, wouldn't it? And then minus 4, times that by a quarter, wouldn't you? And that would give minus 1. So answer would be 1/4. Right, let's move on then to the next part. So move up to the top. So equation of a straight line then, this is the equation in standard form, y equals mx plus c. It's written in this form most often. M is the gradient, so we can just read off the gradient or the slope. C is called the intercept. It's where the straight line, the value of c on the y-axis. If you put x as 0 in here, the input 0, you'll get the value y equals c, which is here on the output. So that's called the intercept, is where the line cuts the y-axis, the value at which where the y cuts the y-axis. That's a standard form for equation of a straight line. You also see this as a fairly standard form, ax plus by plus c equals 0. Both of these are just, you could just rearrange this, couldn't you? Move the y over here, you'd have mx minus y plus c equals 0, wouldn't you? So we just scale, that's just scaled down by a constant multiple. That's all of sort of same in principle as this for this arrangement. So if we were to sketch this, all you'd need to do is, this is in standard form, there's our gradient. So basically, if you're thinking about how to draw the line, you draw it like that, because the triangle is 2/1, the slope is 2, which is 2/1. So there's your triangle, so that's the sort of slope. But you don't really often, for the purposes of the sketch, draw it as steep as that, because you don't really want to do that. You just draw it fairly steep. When x is 0, you get y equals 1, don't you? So there's the intercept. So we want a fairly steep line to illustrate it. Here we go. Trying to draw a straight line with a digital pen. And you label it y equals 2x plus 1. And you can also see that that's true because if you input 0 here for x, the input value, the output would be 1. If you inputted 1 here, the output is up to 3. So it's different scale, but that's the value 1, 3. And if you inputted 2, put 2 in here, you get 2, 5. 2, 5, and so on. And if you came back here at minus 1, which would be, because I haven't drawn it steep enough, was minus 1? Yeah, it would have to be here minus 1. Rather badly drawn line. Because when you put that in, you get y equals minus 1. So that's rather badly illustrated sketch, but that's in principle. So when x is minus 1, y is minus 1, isn't it? Because you put minus 1, you get minus 2 plus 1 is minus 1. So there's the point there. Okay, good. So when x is, that value there would be when x is minus a half. Because you get 0 for y, wouldn't you? Okay, good. So that's that sketch then, illustrated. So let's have a look at this one then. Let's write this in standard form. Y equals minus 7x. Write the second term first and the first term second. Now it's in the correct form, we can just circle the number of x's and label it m, and circle that value there, plus 3, and label it c. So m equals minus 7 then. Gradient is minus 7. C equals 3. So if you were sketching it, you'd have an intercept of 3 and a negative steep slope. So you'd want to draw a really steep straight line, as steep as you can, for the purposes of the sketch. Not incredibly steep because the sketch doesn't illustrate it well otherwise in those cases. So a little sketch of a fairly steep line. This one, so let's rearrange. So leave the 5y as is. Move the 2x over to minus 2x. And move the 8 over to plus 8. Then we can move the 5 from times to divide on the other side. Minus 2x plus 8 all over 5. Now if you add 3 plus 2 say over 7, that would be 3/7 plus 2/7. That's how you split a fraction up. So it's no different in principle, even though there's more awkward terms in this example. So it'd be the first term over what's underneath, minus 2x over 5, plus the second term over what's underneath, 8/5. So our gradient then is the number of x's, and our intercept is that value there. There's m, there's c. So we can read off the gradient and intercept. Is equal to minus, so it's a negative slope, but it's minus 2/5 or minus 0.4. So it's a shallow negative, and the intercept is 8/5, and that's equal to 1.6. This is equal to minus 0.4. So if you were sketching it, for example, the intercept is 1.6. That's the height, and it's a shallow line going downwards, negative slope, so it's going downhill. Supposing you're facing in the forwards positive x direction. Okay, so that brings us to gradient then. There's the steeper and steeper and steeper. Parallel lines have the same gradient because the same slope. Oh, we've done all this. I'm just reviewing what we've done before. So I'm not going to go through that again. So we'll move on to the next section of notes now. Okay, let's finish off with a tiny bit more in the notes then. If you were writing these equations, x equals 2 or x equals 4, the value x equals 2 is here, but it stipulates no condition on the y's, so it's basically the vertical line at x equals 2. So that's how you represent a vertical line. Same at 4, that would be that vertical line, so that's how you would write those. Horizontal lines, there's the line y equals 3, and y equals minus 1 is that horizontal line there. So this is how you write